Well, Dave, here's your kit. Right now I have it operating at 75.3 volts, and I can go up to 80 with this, but that's the most I can do with this current setup I have, because I have 75 volt FETs, and about 81 volts is about as high as I can go before I blow them out. So this is just for a test, but as you can see, it will go down to 58 volts. I have a little power supply boosting up the solar panel, so this is not very realistic in operation. But you should be about 75, 76 volts. You will get this heat sink. These two FETs I said are 75 volts. You will get a 110 N15. That's 110 amp and 150 volts. So that'll be sufficient for your application. All the black wires and the white wire from this board go to the common. This is just like a number 14 wire from the two sources. You add in this little noise filter, and the heatsink is the common drain for the FETs. It's preferred to connect right onto the heatsink rather than going through these leads. This is a board that I had modified from some other video, and I figured it was just easier to set this up than go through everything else. So it's just a plug-in. You go to this pot. The orange wire over here has a PV sense resistor, and that determines the voltage of the pot. The brown wire is the wiper, and the black wire is the low side. There's a resistor in this heat shrink. I'll add some extra resistors. If you put the resistors in series, that'll raise the voltage even higher. So you could try, I don't know, close to 120 volts with this. And like I say, this is the board. You can just free mount this with this plastic clamp. The board, where I have at home, I use a lot of PVC trim work, and I just cut up little blocks, and I use those as insulators. That you could do that with this or whatever. You'll get several of these brand new caps. They're 1200 microfarads at 200 volts, and that's about it. Should be an easy connect together. The gray and purple leads go to the gates of the FET 1 and 2. Both these FETs turn on at the same time, so it's going to have a very low on resistance with those two FETs in parallel. So you won't have really any heating. If you see any heating, something's wrong. So let me just show you the waveform I have here. This is the signal driving the FETs, and this is the high voltage, and when it's down low, it's providing power to the heater. And you see it's really hard to see this very gradual slope. It's around a half volt that it takes to recharge up. This is a very short time period right now. We're only at about 41 watts. I think it was at 45 when I did this. It's a terrible, miserable day, but it demonstrates what it's doing. I think you won't have any problem with it. So I'll be contacting you. Have a good day.